Okay, hello everyone. Welcome to our channel Code with Sunny, and in this video I will be talking about the problems of Google Kickstart round C 2021, and the very first problem is smaller strings. Then we will discuss the further problems, alien generator, rock paper scissors. I think the contest is a balanced contest. The many people have solved the problems of C and D also. Edicto as first over here. Okay, so coming back to this problem, the very first problem, smaller strings. Actually, I haven't given this contest. I have been quite busy nowadays. So after the contest has over, then I've looked over the problems. I think I should have to have solved the problems and make a video for you guys so that you can't have any problem while solving this question. If you're stuck upon any concepts, then you will come back to this video and then you will check out your problems and then you will solve it out and improve your coding skills. Okay. So we have been given an integer k and a string s, and string s would be of length n. Okay, let me zoom it out first. And it would consist of lowercase letters from the first k letters. That is, if we have been given a string s and its length is n, and we will be given corresponding with that the value of k, which will going to denote that the string must contain the lowercase letters from the first k letters of the English alphabet. Find the number of palindrome strings of length n which are lexicographically smaller than s. Okay, and consist of lowercase letters from the first k letters of the English alphabet. Okay, and basically we need to construct a palindrome string from such that that string would be lexicographically smaller than the given string s. And note that we can make many such strings of that type. If you're not going to understand this till now, no need to worry about. I am just explaining the problem statement, and then I will also explain this with the help of examples. Then we will together build it up the solution for this ever problem. Okay, and we have to a number of such strings can be very large, that is the number of palindrome strings where every character must be among the first k letters of the English alphabet, and we have to take it with the modulus test cases, then n and k, then the string of length n. Okay, so the maximum n can go up to 10 power 5. So we should think for an efficient approach to solve this problem. So let's move further to understand this problem with the help of examples and then find out the optimal and the best solution of this problem. Let's move further. Okay, so consider this example like character C, D, E, that is the string C, D, E, F, G, and H. Okay, now I should have to find out the all possible strings such that that string should be palindrome and that string should be lexicographically smaller this than my current string, this one, and only the characters corresponding would, that is only the characters that should be present in that string would be k, first k character. So let us say k equal to 2. So the only characters allowed are a, b only, and I need to find what are the total new possible strings consisting of only characters a and b, and that string should be strictly, or you can say lexicographically smaller than my current string, and that string should be palindrome. Okay, so we have been given a lot of cases. Okay, so no need to worry about. Now starting with the base concept, that is the string should be palindrome. Okay, so whatever character I should put over here, that is in my new string, that character should also present over here. Okay, and whatever character that I should press pick over here, or you can see the put over this position, that character should also be put over this position. It doesn't matter that what the character should be put in over here. I need to focus over the first half of the string. Okay, so if I will put some character x, then this position will be automatically filled with x to make the string palindrome. So it means that we must have to focus first half of the string rather than focusing on the entire string, because we have to make the palindrome. That is the only this one. Okay. So if n is going to be odd, you need to take care about that the middle position will have that is the string would not be like symmetric. I think the middle position will be shared by two halves. That is, if you have n equal to 3, a, b, and c, then b would correspond to like the exact middle one. And here you can see my three characters is present over the left one, then three present over the right one. Okay, now coming back to this problem, that is C, D, and E. I need to find that I need to find out total number of lexicographically smaller strings such that, note that I'm focusing on the CDE only, that is first half of the substring, first half of this string. Okay, total number of ways to find out the string such that this new string should be lexicographically smaller than this string, and the string should comprises of the characters of only A and B. Okay, now comes the major part. Okay, now you can easily see, if I will talk about this string C, that this character C. So if I will place a character A or B over to this position, that is the characters whose ASCII values is going to be strictly less than the ASCII value of the character present over this index, then it doesn't matter what character we will put over these two places, that is the all the characters present between the I plus 1th position up to the mid position. It doesn't matter what character we will put over this position among all the characters that we are being allowed to do so. It doesn't matter what character we will put, the string will always be lexicographically smaller than my original string, and the reason is quite simple, because I've already made my first position characters strictly less, whose ASCII value is strictly less than the original string ASCII value character at this position. Yes, I am right. Because if I will have my, let's say my name starts with Sunny, Sunny, and let's say I will have another string such that whose, let's say whose name would be like Vivek, then you can see if I will make my first position as whose ASCII value is less than this V whose ASCII value somewhere but greater than S, I can have, it doesn't matter what character we will put over this position, my string starting with S will always be lexicographically smaller than Vivek. It is obvious. Okay, so it means that my first position will have the values, will consist of number of ways, will be like 2, and my remaining positions can hold the values, that is my this position can hold the value any values among k, my this position will hold the value any value among k, so it would be like k square. Okay, so if you generalize this statement, my you can say base would always be k, and my exponent will be varying. How it is varying? Mid minus I minus 1. If you're not going to understand this statement, no need to worry about. It will be clear with a few more examples. Okay, so this is CDE. I've already talked about this character at this position C. Now talking about the character at this position D. I need to find the lexicographically smaller string than my original string. You need to repeat this statement so many times to keep in your mind very clear the problem statement. Now comes this position. If you put the characters to make our new string lexicographically smaller. Now I'm not talking about this position now. This position will always hold the value C, because I have talked about AB positions. I need to talk about the C position. So I will fix the character at first position, that is C. Now I'm talking about the second position. Now you can see the second position already has the character D. So I will put a character A, B and C at this position. You can easily see my string would become always lexicographically smaller than the original string. If I will put the ABC, any of the character among this ABC on the second position, because these characters have the ASCII values strictly less than the character at second position, which is D. Okay, but you can easily see I have the allowed characters of only A and B, so I am not considering this C. So what is the number of waste at this position? It is 2 into, it doesn't matter what character I will put after that, that is after this I position, that is starting from I plus 1 up to the mid, because I need to consider for the palindrome condition also. So I am only considering up to the mid value, mid position, I plus 1 up to the mid, that is E, and you can easily see this remainder, that is the base would always be K, and exponent would be mid minus I minus 1. If I will consider zero based indexing, so mid is coming out to be, you can easily see 6 by 2, it is 3, minus I would be 1. If I will consider the zero based indexing, minus 1 3, minus 1 2, minus 1, K power 1, that is the only E1. Okay, so my answer would be incremented by 2 into k. Previously, my answer would be incremented by 2 into k square. Now coming back to this E position. Okay, so my E position I am talking about. So you can easily see this will also have the characters like A, B, C, D, E. If I will A, B, C, D only, if I will choose any of the characters among this position, then all the characters after that, it doesn't matter what we will put. But you can easily see the characters allowed are A and B, so I will not consider C and D. So my answer would be incremented by 2 into, and there are no more characters to the right of it. Since I need to consider for the palindrome, I need to consider the characters up to middle one, 2 into k power 0, which is coming out to be 2. Okay, now these are the answers, but can this be a sufficient answer? No, obviously not. How this is possible? Now consider this example only. Now you can easily see, starting from this left one, what I have done is, if I am talking about this C, I've talked about only A and B. If I'm talking about this D, I have considered, I've fixed this character C, only C. And I've just talked about, for this D position, I've talked about A and B. Then I have fixed this D position, and for this E position, I've talked about A and B. Now after that, I need to just consider the characters only, the equal to the original string. That is only C, D and E. Okay, now this is going to be like really, really important. How this is going to be really important? If you focus over the constraints, that is string s of length n, and it already consists of lowercase characters from the first k letters of the English alphabet. So it means that I've just taken a wrong constraint over here. Don't be worried about, since this string would already consist of the characters among the first k letters. I have taken the ks2, and this example seems to be wrong, but it is quite a good one for understanding the problem. Since k over here should be equal to, I think I can modify this. Should be yes, I can modify. I can take k as 3 or 4, and I will eliminate this fgh also. Okay, or I will take k as 4, 5, 6, 7, 8. Okay, so don't be get confused. This example is good, but you must take care that the original string should also consist of characters among the first k letters. Okay, so let me pick up one example from here, that is B and C, and I will explain how my answer should be incremented by 1 by considering only a small corner case, and how this is going to help us. So if I will consider my characters only B and C, I have k as 3. Okay, so it means that for talking about this B position, I can have only A, and if I will have A for all the characters to the right of it, since I have to consider only for the middle positions, it doesn't matter. So my one of the string would be like A and A. But you can easily see, if my k is 3, I have the allowed characters A, B and C. I can modify my original string also. How can I modify that? Since I need to make a palindrome, I will fix this B, and I will correspondingly make another B also. So B and a B. Okay. So this is also lexicographically smaller than this BC. And in the same case, in this example also, C, D, E, F, G, H, if I will make a character like this one, C, D, E, and all this character is same, corresponding the palindrome, to make the string palindrome, I have to consider like this one, E, then D, and then C. C, D, E, E, D, C. This is the new string, and if this string is lexicographically smaller than this string, which is, I think, yes, then our answer should also be incremented by 1. This is the main corner case. Okay. Now this is the whole entire problem. You need to just traverse from I equal to 0 up to this mid and check it out. If that is, increment your answers by with respect to the positions. How the position should be incremented? Find the ith character and find the difference of ith character with small a character. That is, if it is C, I need to find the ASCII value, difference of ASCII value C and small e, and it would come out to be 2. Yes, it would come out to be 2. It means that A and B characters are allowed only 2 characters, and find the minimum of this value with K. It means that these, let's say minimum is X. It means that X amount of values is possible at this position, and for the remaining position to the right of it, the characters possible is k power mid minus I minus 1. You need to calculate this power of this power efficiently in log of n time using binary exponentiation. Otherwise, you will get a TLE. If you are not aware of this concept of binary exponentiation, do check the description section of the video for the tutorial of this binary exponentiation so that you can solve this problem efficiently under the given time constraints. Then solving this for every I starting from 0 up to this mid, and also finally you need to check here that if I will take my half of the string and make it a new string such that this half of string and the corresponding reverse of this half of the string will appended together will be a palindrome, and this new string is lexicographically smaller than my original string, then I need to increment my answer by 1 also, like in this case CDE okay, and also for in this case also like BC I can make this BB. I need to increment my answer by 1 finally also. So let us talk about the code, and we will together understand this one, and I will explain the in detail also. You can easily say I have a binary power function which is going to calculate a power of some number in a of a log of n times. So power of a comma b in log of I can say max of okay, so in general I can say log of n time, and n can be the power exponent, you can easily say. So if you're not aware about this, do check the binary exponentiation tutorial. Now coming back to the solve function, you can easily say I've taken n, k and string s and find the mid value corresponding to n being odd or even. Okay, then this is going to be mid, and I will find the minimum. First minimum of this value, that is if my value is c, my allowed values are a and b, and now this it has to be depend upon k. How much k is k can be bigger, but these two characters are allowed, so I need to take the minimum also every time. So minimum is mn, so my answer would be incremented by number of values taken for this ith character, and it doesn't matter what characters being to the right of this position, then I will have the k power mid minus I minus 1. My answer should be incremented by this position. Note that I am also maintaining another string to make a palindrome string of first half characters using the first half of the substring and taking the reverse of it and then appending together. Okay, and finally if I am checking if my new string whose which is lexicographical smaller than original string, I will increment my answer by 1 again, and finally return the answer modulus this prime number. Okay, so let me copy this code and submit once again. Okay, so if you are unaware about the concept of how to calculate the power, then you need to take care for that also in log of n time. Okay, it will be like fast exponentiation. So I think yes, it would pass, obviously pass, because it would have a good time limit under the constraints of this one. Okay. So you can easily see both the test cases are passed. If you have any doubts, do let me know in the comment section of the video, and I will ask the viewers to like this video, share this video, and to subscribe to our YouTube channel for latest updates. Thank you for watching this video.